So right here I have my basic down counting circuit. I have my 3D flip-flops with Q going to the clock, which is going to set up my down counting. I've gone ahead and taken my Qs out to my DCD hex to go ahead and display right there. And I have my chip down here that's going to do my reset logic. This is to build a basic down counting circuit. To do that, I need to detect what I want to end my count at, and that comes into the input of my 3-input NAND. The output of my 3-input NAND will determine what my count starts at the next time around. So in this example, if I want to go ahead and build a 4 to 0 down counter, what I always need to do with asynchronous chips like this is that I need to actually detect one beyond what I want to build. So if I'm building 4 to 0, I want to actually detect the number after 0 on a down count, which with 3 bits would be a 7. So I want to detect a 7 because as soon as the circuit detects a 7, it's going to go ahead and reset or clear my chips. So to detect a 7, I want Q to be on all 3 bits. So I'm going to just connect my input into my 3-input NAND to all 3 Qs. That's going to detect a 0, or that's going to detect a 7 because 0 is my last count on my down count. So it's going to go 4, 3, 2, 1, 0. Then for a moment it will throw a 7, which this detects. So we go 1 beyond. I said it needs to be a 4 to 0 down counter. So now I want to set it to a 4. This is my most significant bit. It flashes on and off the least number of times. So that's my 4s, my 2s, my 1s. So when it resets, I want this to be on, off, off. To set it to on, I'm going to connect it to preset. To set it to off, I'm going to connect it to clear. That's why we used a NAND so that it outputs a low level when our circuit detects the number we're looking for there, because these are low level activated. So I've detected a 7. I've told it to reset to a on, off, off, or 4, 0, 0. 4 is the number we're looking for. So it should go ahead and detect a 7, reset to 4, count down to 0, detect a 7, which we don't see, and continue to repeat that cycle. I need to send power to the other presets and clears that I have not used. That way they don't float low. Now that I've created that circuit, if I turn on my switch here, 4. Okay, so there's a little bit of a glitch on this one. So I'm going to have to go ahead and troubleshoot what that's doing to me. So if I look at this situation, it's supposed to count a 4 down to a 7. One of the flaws that we have that I was waiting for a student to discover is on a 4 to 7. Something like this, what it's detecting is when this is high, and this is high. So what it's actually doing to me is we've got a 4, and as soon as it goes to trickle down, it's going to go ahead and turn on these 2 gates, and this one hasn't shut off yet due to the ripple count. So it's going to go ahead and detect this one still on with these 2 coming on. It thinks that we've hit 7 even though we're transitioning to a 3. So it's actually just saying 4, going back to a 4, going back to a 4. So a 4 to 0, which is detecting a 7, would be a bad idea. So what I'm going to do is I'm going to modify this one so that it's going to instead be a 4 to 1 down counter. So I'm going to detect a 0 and reset it to 4. So that means I could have actually left those outputs there because I want to reset it to 4. And I'm going to detect a 0, which would be all of these off. Now that I've set that up, I'm going to go ahead and hit play. 3, 2, 1, 4, 3, 2, 1. So it's a 4 to 1 because the 0 didn't work that detected for the 7. So that's how we went ahead and set up that circuit.